morning. I hope you're having a good day so far. Today we're going to talk about arithmetic sequences. So an arithmetic sequence is a sequence in which the difference, so again, I'm going to say that you're writing this in this line right here, okay? So I'm not writing it at this moment just because when I write it, it's really, really big. So it's a sequence in which the difference between any two consecutive terms. So again, a sequence in which the difference between any two consecutive terms is constant. All right, and if you need to pause it to get that written down, that's perfectly fine. One more time, a sequence in which the difference between any two consecutive terms is constant. Okay, and then our common difference is the difference between two consecutive terms. All right, so again, the common difference is the difference between two consecutive terms. If you need to pause it to get that written down, go ahead and do that. All right, what we're going to do is we're going to look at whether a sequence is an arithmetic sequence or not. So the way that we're going to determine this is we're going to look at, is the same thing happening each time? Are we adding the same value each time, subtracting the same value each time to make sure they're the same? If they are the same, we'll say yes, and we'll identify what we're adding by. If they're not, we'll say no. So looking at number one, oh, my Theo, if you can hear him in the background, is playing with a T-Rex. Okay, looking at number one, it goes up by 4, up by 4, up by 4. So this is going up by the same number each time. So we would say yes, and D equals 4. Okay, looking at number 2, it goes up by 2, and then it goes up by 3. Okay, it changed right there, so we would say no. And we won't say D equals anything because it doesn't have a common difference. On number 3, it's going down by 2, down by 2, and down by 2. So this is doing the same thing each time. So we would say yes, and then since it was going down, we would say D equals -2. All right? So you try 4, 5, and 6. So pause it, come back and see if you got the same thing. Okay, on number 4, you should have gotten yes and -3. On number 5, you should have gotten no. And on number 6, you should have gotten yes and -1. Okay, on this next part, our job is to just find the pattern and continue it. So find the next 3 terms. So looking at number 7, it goes 9, 13, 17, 21. Okay, so see if you can find the pattern. It looks like we're going up by 4 each time. So I'm going to do 21 plus 4, which is 25, plus 4 again, which is 29, plus 4 again, which is 33. Okay, on those next two, see if you can find the pattern and find the next 3 terms. Okay, so that means pause it if you didn't. Okay, on number 8, you should have gotten -7, -10, and -13. It was going down by 3 each time. On number 9, you should have gotten 16, 22, and 28. It was going up by 6 each time. Okay, so now we're going to talk about how to find the formula and how to find a specific term. So our formula for an arithmetic sequence is going to be AN, so it's A sub n, that's a little n, equals A1, again that's a subscript, plus D times n minus 1. Okay, in here, D is what's known as our common difference, so our pattern. I'm going to abbreviate it. And then A1 is our first term. Okay, so those are the 2 things that we need. We need our first term and our common difference. So number 10 says write a rule for the nth term and then find A19, which is just the 19th term. Okay, so I need two things. I need my first term and I need my common difference. So my first term on number 10 is 7. And then I need to know how much is it changing from 7 to 13. Well, from 7 to 13, it went up 6, so that's my common difference. So I'm filling in my formula. AN is equal to my first term plus my common difference times n minus 1. Once I've filled in my formula, I need to distribute my common difference. So that's going to be 7 plus 6 times n is 6n, and 6 times that -1 is -6. And then I'm combining my like terms. So this will be 6n, 7 plus -6 is +1. Okay, so this is my first answer. It asks for an equation, so it asks for the rule, and then it asks for the 19th term. So once I have the rule, I'm just going to plug in 19. So I'm going to do 6 times 19 plus 1. And that I can just plug into my calculator, and when I do, I get 115. Okay, so trying again. Our first term is 30, and then I need to find my common difference. So what is happening from 30 to 26? From 30 to 26, we are subtracting 4. Okay, so we're going to do AN is equal to our first term, which is 30, plus -4 times n minus 1. Again, same steps. I'm going to distribute, so this will be 30. This is -4 times n, which will be minus 4n. -4 times -1, which would be +4. Combine my like terms. I get -4n plus 34. Okay, so this is my rule, and then I'm going to plug in 19. -4 times 19 plus 34. Okay, so that little 19 is telling you what number to plug in. Okay, when I do that, I get -42. Oh, bless you. All right, so this is a good space for you to pause the video and try those next 4. Okay, so find the equation on the next 4, and then find the 19th term. Okay. All right, hopefully you found your equation, checked in with your group, and found the 19th term. I'm going to tell you what they are really quickly. So on number 12, you should have gotten 3n minus 14, and then 43. On 13, you should have gotten 2n minus 4, and then 34. On number 14, you should have gotten -5n minus 11, and then -106. On number 15, you should have gotten -9n plus 10, and -61. Okay, and then we're going to do some applications. So, you visit the Grand Canyon and you drop a penny off the edge of the cliff. The distance the penny will fall is 16 feet for the first second. Oh, goodness. 48 feet the second, and then 80 feet the third second, and so on, keeping the same path. Write a formula to represent this sequence. Okay, so it starts at 16, and then it goes up to 48, so that would be 32, and then up to 80, which again is 32. So it does have that repeating pattern, and I can find my formula. So my formula for this is going to be AN equals my first term, which is 16, plus my difference, which is 32 times n minus 1. Okay, I'm going to distribute, so 16 plus 32n minus 32. And then combine my like terms, 16 and 32. This would give me 32n minus 16. Okay, so this is my formula. This is my answer on part A. And then it says, how far will the penny have traveled after 6 seconds? So I'm going to do 32 times 6 minus 16. Okay, so when I do that, I get 176 feet. All right, last one. Oh, don't be cranky. You're fine. The total bank loan for Sarah's new car is $15,265. The bank automatically withdraws $295.80 each month to pay off her car. Write a formula to represent this sequence. Okay, so this problem is a little bit different than the other ones. We don't know how much she paid her first month, and you could find it, but you don't need it. This is her starting value, and this is how much it's changing. So arithmetic sequences are a lot like linear functions. So since it gave us her starting value, not how much she's paid, not how much is left after the first month, it gave her starting value, we can just go straight to our formula. This withdraw means that they're taking money off of it. So that means it's going down. So her formula is going to be negative 295.80 in, and then plus the amount of that she's starting with, the 15,265. Okay, again, because it didn't say after the first month there was this month, and then the second month this month, and then the third month, that is her starting value. So we can just use that as like our y-intercept, our slope and our y-intercept. And this is the other part that gets a little tricky for some people. What is the balance after 2 years? Okay, well, this is not in years, this is in months. So be careful, we don't want to use years. How many months are in 2 years? 24. Okay, so what we're going to do is we're going to plug in 24 to that. So we're going to do negative 295.80 times 24 plus 15,265. Okay, we're going to plug that into our calculator, and when we do, we'll get that after 2 years, she has 8,165 and 80 cents is how much she has left. All right. Okie dokie. Well, I hope that helped, and I hope you have a great rest of your day. Bye, guys.